Today, we are going to dive into the secrets of solar power. And I'm not just talking about pointing a panel at the sky. Nope. We're talking about how to squeeze every last drop of energy out of every single sunbeam. Let's get into it.
It really seems like a simple question, doesn't it? You put up a solar panel and the sun does all the work. But to get maximum reliable power day in and day out for, decades, well, that is a whole other story.
Because you see, turning sunlight into electricity isn't just about the panels themselves. It's really about a symphony of brilliant engineering. Everything from the initial design to intelligent operation and, of course, lifelong quality control. It's a system where every single part has to work in perfect harmony. And to really understand why getting this system right matters so much, we need to go beyond just the theory. Let's look at a place where reliable solar power can literally change everything. So let's take a look at Ghana. Now, like many developing nations, its economy is growing, its population is expanding, and so is its need for energy. We're talking a staggering 10% increase every single year. That is a huge demand to meet. So here's the situation. On one hand, you've got the challenge of a really unreliable power grid, with regular outages that can just stifle growth. But on the other hand, you have this incredible potential. Ghana is bathed in sunlight, with enough solar resources to generate a massive 53,000 megawatt hours a year. The solution is literally right there, shining in the sky. Okay, so how do you turn all that potential into actual usable power? Well, it all starts with the blueprint, the design of a truly high-performance solar power plant. And this isn't guesswork, not at all. It's a meticulous process where every step builds on the last. It all starts with the load demand. How much power do you actually need? If you get that wrong, everything that follows is going to be either too small to work or way too big and wasteful. And only then can you correctly size the panels, the inverter, the batteries for storage, and the charge controller that protects the whole shebang. And this brings us to a really key design choice. Do you go with a sleek integrated unit that combines the inverter and charge controller? Or do you opt for separate components, which, can often be more cost-effective? It's these kinds of engineering trade-offs, made right at the very beginning, that determine the success of the entire project.
So we've got the blueprint, and the components are chosen, but a perfect plan always meets a messy reality. The sun doesn't shine perfectly all day. So how do you make the system smart enough to handle constant change?
This is the classic solar power problem. A perfect sunny day can be interrupted in a split second. A passing cloud, the shadow of a building, even a little bit of dust or a bird dropping on just one panel. So what happens then? You might think it's a small issue, but as the experts at Fraunhofer ISC point out, it has a massive ripple effect. Shading on just one tiny part of one panel can drag down the performance of an entire string of panels it's connected to. The system's output can just plummet. Now, to understand the solution, we need to talk about the maximum power point, or MPP. Think of it as the perfect sweet spot, the exact combination of voltage and current where a solar panel is producing the absolute most power it possibly can under whatever the current conditions are. And this right here is where the problem gets really tricky. On a perfectly sunny day, that power curve has one clear peak, one obvious maximum power point. But as soon as a shadow hits it, that simple curve becomes this complex mountain range with multiple peaks. A simple system can get lost, settling on a false peak and producing way less power. And the solution is a brilliant piece of technology called maximum power point tracking, or MPPT. The car analogy is perfect. It's basically the system's brain, constantly scanning that complex curve, ignoring all those false peaks, and hunting for that one true gear, the global maximum power point, to make sure the system is always running at peak efficiency no matter what the sun is doing. Okay, so we have a great design and a smart operating system. Fantastic. But a solar plant is a 20-plus year investment. So how in the world do you guarantee high performance not just on day 1, but on day 7,000? This is where the quality assurance cycle comes in. It was developed by the Fraunhofer Institute, and you can really think of it as a comprehensive, lifelong health plan for a solar power plant, covering it from the planning phase all the way through its entire operational life. This health plan has 4 absolutely essential stages. First, it starts with the plan, a yield assessment to predict performance before a single panel is even bought. Then comes the checkup. You lab test the modules to make sure you actually got what you paid for.
After construction, it's time for a stress test to confirm the whole system works exactly as designed. And finally, you have the follow-up, continuous yield monitoring for decades to catch any problems and ensure peak performance.
And if you're wondering if all that effort is really worth it, just look at these numbers. For a large solar plant, a tiny, almost unnoticeable 1% drop in a panel's power can translate into a €60,000 loss over its lifetime. See? Quality assurance isn't a cost. It's an investment that pays for itself many, many times over.
So, from the initial design to smart operation and long-term care, what's the big picture here? Let's distill it all down.
Achieving maximum solar power really comes down to three things. It has to start with a smart blueprint, a design meticulously tailored to the specific energy needs. It absolutely needs a sharp brain. That's the MPPT technology that can adapt in real time. And it all depends on a vigilant guardian, that comprehensive quality assurance cycle that protects the system's performance for its entire life.
And ultimately, this quote really says it all. You just can't skip a step. To unlock the full potential of a solar power system, you need that complete, closed loop of quality assurance right from the very beginning. And that leaves us with a pretty critical question for our energy future, doesn't it? As we continue to build out the solar infrastructure we all depend on, the focus can't just be on speed. The real challenge is making sure every single installation is engineered not just to be built, but to be built to last. Thanks for joining us.